that would start to diminish. And this would continue on until you reached a few kilohertz. And again, by 5, at most 10 kilohertz, there would be all of the energy would be traveling in the twisted wire pair, and there would be absolutely no field coupling to the other two wires hanging off of the negative wire. Hence, there would be zero electron movement in those two wires. Low frequency energy has to be channeled. You have to pay attention to where it is and channel it. High frequency energy will self-channel. It will. You can put. I've had many people ask me, why isn't a ground plane a ground loop? Because the places where we use them are at high frequencies where the energy will self-focus. It will focus itself where it needs to be to keep the fields contained. And so we don't have to worry about stray currents going hither and yon. And that's why you don't need to split ground planes in most circuit boards. At really low frequencies, in order to contain the low frequency fields, then it may be necessary to split the ground plane. But we haven't even done it in circuits I've worked on, even at low frequencies. We've located the low frequency analog components, so there was very little risk of the energy drifting away from where we wanted it to travel, and then we didn't have to worry about it. What would this be used for? You've got 4 circuits, and you've got wires connecting signals from circuit 1 to 2, and 1 to 3, and 1 to 4, and 2 to 3, and so on and so on. And there's a star ground, a single point ground, hanging off of the bottom of the 4 circuits. Where does this get used? The answer is at audio frequencies, because at the frequency range of audio, which is much of it is under 10 kilohertz, at that frequency range, if I send energy through the bottom wire between circuit 1 and circuit 2, if I attach a signal to that wire, the return path for it is going to be that ground wire going from the bottom of 2 through the star point and back to circuit 1. And yes, the fields are going to spread out to create forward and return current in those 2 wires. Yes, it is. But at low frequencies, as long as they're not a really long distance, they're not going to be a distributed length. They're going to be a lumped length. And so do we care? In most cases, no, we don't. As long as some other energy source can't interfere with that loop. That's a reasonably large loop, that area between the signal wire and the ground. But as long as there's no energy in the system at a frequency that can interfere with a loop that size, it's going to work just fine. If you take the bottom wire going from circuit 1 to circuit 3, you ask the question, where's the return path? The return path is in the quote-unquote ground wire from 3 through the star point and back to 1. And this whole concept works for no matter which wire you put signal in relative to ground. You can see where the return path is going to be from circuit 1 to 2 or 1 to 3 or 2 to 3 or whatever. We can see how things are going to function. At frequencies above 10 kilohertz or so, where is the return current going to be? Well, the answer is the return